All right, this video is on right triangle trig word problems. So when I say right triangle trig, what I'm referring to is SOHCAHTOA. So right triangle trig. So when we solve these word problems, we're going to use sine, cosine, and tangent. We are not going to use the other three trig ratios because they don't have buttons on our calculator. And that's the only reason we're not going to use those three. All right, so when you are working out these word problems, the first thing I want you to do is draw a picture. It helps if the picture is a little bit realistic, like if it's talking about a tree, draw a tree instead of a straight line. The reason I say that is when your picture is somewhat realistic, it helps you to use your common sense within the problem. If you're just drawing triangles and labeling things, then I find students sometimes make silly mistakes that they wouldn't have made otherwise. So first, always draw a picture. Second, you're going to pick a trig ratio. And solve. And the trig ratio that you pick is going to be based on the information that you have. So it's not like you just get to pick any of them. It's like you figure out if you have an angle and then you have the side opposite of that and the hypotenuse, then you know you're going to be using sine to solve that triangle. All right, so for example, we're going to say a 5-meter long ladder leans against a wall. That's not a period, comma. With the top of the ladder being 4 meters above the ground. What angle does the ladder make with the ground? All right, so I'm going to draw a picture. Right here I have the wall. You'll see that sometimes I label my pictures when I can't draw something special that looks like that. There's my ladder. So the ladder is 4 meters up the wall, and the ladder itself is 5 meters long. So here is our right triangle right in there. And if it helps you to draw the picture and then draw the triangle on top of the picture, you are definitely free to do that. So there's our triangle. The angle that we're trying to find is the angle that the ladder makes with the ground, which is right here. I'm going to call it theta. That's the typical variable. That was what I was looking for. That's the typical variable we use to represent an angle. So I'm going to say that if this is the angle, then that means that this side is the opposite side and this side is the hypotenuse. And so I'm going to say that sine of the angle is opposite over hypotenuse. And then to go ahead and solve for theta, I just need to get rid of sine. So I'll do sine inverse on each side. So theta is going to equal sine inverse of 4/5. And so in my calculator, I'm going to hit the mode button first, and I'm going to make sure that my calculator is in degrees because when we work with triangles, we work in degrees. And then I'm going to go ahead and hit second sine to get sine inverse up there of 4/5. And I get 53.130 degrees. So the angle is approximately 53.130 degrees. Since this is a story problem, we get a story answer. So the ladder makes a 53.130 degree angle with the ground. All right, now when we look at these story problems, there are two phrases that are very common for these story problems that we need to write down so that we understand what they're talking about. So the first is angle of elevation. And the way that angle of elevation works is it's like you're looking straight out and up. And so that's the angle that they're talking about. Angle of elevation, straight out and up. Angle of depression is straight out and down. So it's not any angle that's going down, you have to be straight out and going down. And so most students draw angle of elevation just fine, but many students draw angle of depression incorrectly. So that's something to watch out for when you do problems. Okay, so we're going to go ahead and do another example or two using some of these, this way of phrasing the problem. So we're going to say a tower casts a shadow that is 60 feet long when the angle of elevation of the sun is 65 degrees. How tall is the tower? All right, so first thing, we go ahead and draw a picture. Now, I'm not very good at drawing towers, so my pictures are not going to be very exciting looking, but it'll still work. So maybe it's got like a triangle top, right? Because it's a roof. Okay, so there's the tower. Here's the sunshine over here. And then here's the shadow of the tower over there. That looks realistic, right? Okay, so they say the angle of elevation. This looks like an arrow and that doesn't. Is that better? Okay, anyway, angle of elevation, so we remember that means straight out and up. So I have to think, where should the angle be so that it goes straight out and up, and it's referring to the angle of the sun. And so that means that the angle must be right here, because this is straight out and up. So that's kind of like the effect that the sun is having as it makes that shadow. So I'm going to go ahead and say, like, here's my triangle right here, I guess. It looks like my height is the sun, but pretend that I drew that triangle better. So, oh gosh, that was kind of terrible how I drew that. Yeah, I'm not going to fix that. Oh gosh, I gotta fix that. You guys, normally I'd remake that video, but I don't feel like it. Okay. So let's try this again. We have the tower. We have the sun. We have the shadow. There's the ground all the way across. We have the shadow of the tower on the ground. Okay. So the angle that the sun is making is 65 degrees. They tell you that the shadow is 60 feet, and they want to know what the height of the tower is. So that's going to be this, and that's going to be an X. So now we have to think about, if this is the angle, that would make this the opposite side, and that would make this the adjacent side. And so that means that the trig ratio that we're going to use is going to be tan. So tan of 65 equals opposite, which is x, over adjacent, which is 60. And then to solve for x, I'm just going to multiply the 60 to the other side. So I'm going to say x is 60 times tan 65. But no one's going to answer a question about how tall is the tower and say the tower is 60 tan 65. So let's go ahead and see what the decimal is. So 128.670. And that was feet. So I'm going to say the tower is 128.670 feet tall. All right, let's try one more. So last example here. Matt is standing on top of a cliff. Um, 305 feet above a lake. The measurement of the angle of depression to a boat on the lake is 42 degrees. How far is the boat from the base of the cliff? All right, so we have, like, here's some rocks, and then we have the cliff going down, and then down here, there's water. Cliff, water. And we have Matt. He's standing at the top of a cliff, and he is 305 feet above a lake. So that means this distance right here is 305 feet. The measurement of the angle of depression to a boat on the lake is 42 degrees. So I'm going to go ahead and draw a boat right here. And it says the angle of depression. So angle of depression means straight out and down. So straight out and down. Sorry, that was my phone. All right, so what we're going to do is we're going to figure out the triangle that we're dealing with here. So we have straight out and down. So that means this is the triangle. And it says how far is the boat from the base of the cliff. And so this measurement right here is what we're trying to find. But you'll notice that these measurements that I have are not on my triangle. So I need to go ahead and label them. So this 305 right here is actually this side of the triangle. And then X, what we're trying to find is actually this. So it's kind of like you can see like this big rectangle right here, and I'm just working with this triangle. Angle of depression right here, straight out and down, 42 degrees. So the reason the angle of depression feels kind of weird is because it's like not the triangle you would expect it to be. So you just need to be careful when we work on those problems. So if we look at this, we have the 305 is the opposite side, X is the adjacent side, and so again we're using tan. So tan of 42 equals opposite over adjacent. And these problems are a little bit trickier to solve because the X is stuck on the bottom. So what I'm going to do is I'm going to put this over 1, and then I'm going to go ahead and cross multiply. So I've got 305 equals X times tan of 42, and then I'll divide the tan 42 over to the other side. So 305 divided by tan of 42 equals X, and so 305 divided by, that wasn't divided by tan 42. And so X is 338.737 feet. So the boat is 338.737 feet from the base of the cliff.